Hi, folks. Today we're going to learn about transformations of linear functions. And transformations are just a change to the size or the shape or the position or the orientation of a graph. And today we are looking at transforming linear functions, which are actually some of the hardest transformations to do. Even though it's the simplest function, and that's why we're starting with it, visualizing linear transformations is hard because changes in the y direction, like these translations, which are up and down, look almost identical to changes in the horizontal direction, like these changes to the left and right. So if you look at the vertical translation up, the blue graph here looks almost the same as this horizontal translation, the red graph on the right. And so it's going to take a little bit of extra imagination and thought as we do these translations. And so I will try to put marks on the graph, like you see these X's here, so that we can track what's happening to a specific point on the line. Because if you look at the line as a whole, you don't necessarily see the difference between vertical changes and horizontal changes. This will be a little bit easier in the next class where we look at absolute value graphs, which are V-shaped. And then there's this vertex point at the bottom that's easier to track, easier to follow. And that's the next class that we'll be doing. But before we get started, let's go over a few definitions. First of all, a family of functions is a group of functions with similar characteristics. So today, the family that we're looking at are the linear functions. In the next lesson, the family that we're looking at are absolute value functions. And there's always going to be a parent function, and it's always the parent function is just the most basic function in a family. So for linear functions, that parent function is f of x equals x, which remember is basically just the same as saying y equals x. And so we're going to look at a variety of different transformations, including translations, which are just shifts. And shifts can be up and down, vertical, or they can be left and right, horizontal. Then we're going to talk about reflections, just like looking at a mirror image of something. Graphs can be reflected across the x-axis, and that's a vertical change, or they can be reflected across the y-axis, that's a horizontal change. Then there can be stretches and shrinks. Horizontally, you can stretch or you can shrink, and then vertically, you can stretch or you can shrink. And so those are all the different types of transformations we're going to focus on today. Notice we can add values or subtract them, and that change can be outside of the parentheses, or we can do adding or subtracting inside parentheses. We can do multiplication outside the parentheses, or we can do multiplication inside the parentheses. And there's a different effect when you do things outside or inside parentheses, and different effects when you add or subtract versus multiply or divide. And so let's look at the kind of summary of the changes that can happen here. First of all, when you add or subtract, there's going to be a shift. There's going to be a translation of some kind. When you multiply or divide, there's going to be a stretch or a shrink or a reflection of some kind. How do you know what kind of shift or what kind of stretch or shrink? That depends on whether you're outside the parentheses or inside the parentheses. So if you see any of these changes outside the parentheses, so like this K is outside parentheses, this A is outside parentheses, you're affecting the output value. You're changing the output value after X has already been through the function machine, and then you add something onto it or you multiply it by something. You're changing the output value. So you're changing the Y values. You're changing what's happening in the Y direction. So whenever that transformation happens outside parentheses, the change happens in the Y direction. So you're shifting up or you're shifting down if you're adding outside parentheses. And you're stretching vertically or shrinking vertically if you are multiplying outside the parentheses. On the other hand, when you're inside parentheses, you change the input values. You change the x value before it even gets put through that function machine. So these are where you're changing the input value. So these causes changes in the horizontal direction. Um, so you're talking about shifting left, shifting right, or horizontal stretches or horizontal shrinks. One other important thing about outside parentheses versus inside parentheses transformations is that when the change is outside parentheses, then the change is what you expect it to be. When you add k, that's an upward shift. When you subtract k, when it's a negative number, then that's a downward shift. Transformations that are inside parentheses often throw people because there is a built-in negative sign into this transformation. And so the change is opposite to what you expect it to be. If you see what looks like a negative number, um, it's actually a shift to the right. If you see what looks like a positive number, being added, it's actually a shift to the left. And so we'll look at examples like that in just a moment. This is kind of an overview so that you can have the summary in one spot. But let's look at examples to see what I mean by this. So in this example, it says f of x is 2x minus 1, and that's been graphed. So 0, -1 is a point on the graph, and 1, 1 is a point on the graph. And I'm going to use different symbols here so we can kind of follow those symbols as we go along. So if I want to transform this graph, if I want to take f of x and then add 3, notice that adding 3 happens outside parentheses. Basically, I put x into the function machine and I do everything we saw before. And then I take that result and then I add 3 onto it. So before, an input of 0 gave me an output of -1, but now I'm going to take that -1 and add 3 more onto it because that's what the equation tells me to do. And that's going to give me an output value of 2. So this circle plotted point before is now going to be up here. If I do the same thing to my second point at 1, 1, I'm going to take that output value and add 3 to it, and that's going to give me an output value of 4. So my square point now gets graphed up here. If I continue that pattern on a little bit just so that I can draw a straighter line, it's going to look like this. And that's going to be my graph of G. So that's an example of a vertical shift upwards of 3 units. Vertical shift up 3. Okay. Let's look at this next example. This next example, it looks like I'm adding 3 as well, but this time the change is happening inside parentheses. So this time the change is going to be in the horizontal direction. And I hinted at this before, but now you're going to get to see it in action. This changes input values, and because this change is happening before the number gets put through the function machine, in order to get the same output value that I have before, if I'm adding 3 to the value, how do I undo that so that I'm still basically putting the number 0 into the function machine? The answer is I have to subtract 3 from it. So basically, we have to subtract 3 from the input value, and 0 minus 3 is -3. We have to subtract 3 to get an input value that still gives us the output of -1. So we have a point. This is the circle point at -3, -1. Doing a similar thing to the second point, the input I want to be 1 so that when it goes through the function machine, it outputs 1, except I'm adding 3 to it. So to undo that adding 3, I have to subtract 3. and that gives me -2. So I have a point here at -2, comma 1, which is this square point. And again, if I just kind of continue the pattern a little bit to hopefully draw a better line, not a great line, but okay. This is my t function here graphed. So notice the difference between a vertical shift up and a horizontal shift to the left. So horizontal shift left 3. And so these are examples of translations, which are one type of transformation. Translation is the fancy word for shift. And your shifts can be up and down if there's addition or subtraction outside parentheses, and it can be left or right if you've got addition or subtraction inside the parentheses. Let's look at the next kind of translation. Here we're talking about reflections across the x-axis and reflections across the y-axis. Especially with simple functions like lines, it can be difficult again to tell the difference between an x-axis reflection and a y-axis reflection. But notice that they're both caused by multiplying by -1. If you multiply by -1, you're going to cause a reflection. Now, if that -1 is being multiplied outside the parentheses, remember outside the parentheses means in the vertical direction, in the y direction. And that means we're actually reflecting across the x-axis. If you're reflecting across the x-axis, that's in the y direction. On the other hand, if the multiplication by -1 happens inside parentheses, it's inside parentheses, so that's a horizontal change. That's because you're reflecting across the y-axis. The way you can tell just by looking at a graph whether it's been a reflection across the x or y axis is across the x-axis, the x-intercept stays the same, and across the y-axis, the y-intercept stays the same. So let's look at this example here. F of x equals 1/2 x plus 1 is graphed. So these points of -4, -1, and -2, 0, and 0, 1 are shown. So I've got kind of 3 different shapes here to represent them. And now I'm going to look at what happens when I multiply by -1 outside parentheses to graph my g of x function. So outside parentheses, let's see, I plug in my -4. Basically, I'm just taking that output value and I'm just multiplying it by -1. So whereas I had -1 before, I now have +1. So multiply times -1. Where I had 0 before, 0 times -1 is still just 0. And 1 times -1 is -1. So these are the new points I need to plot at -4 and +1. This point is still the same. And then I have 0, -1. So I have a point here. And now if I just kind of continue the pattern a bit to help me draw a straighter line. Doing my best here. Okay. And then that is what the reflection looks like across the x-axis. Across the x-axis, that x-intercept has stayed the same. And so if I'm going to describe this, let me just scroll down a little bit. This is a reflect across the x-axis. Reflect across x-axis. Next, I'm going to draw my t function. And notice that here the multiplication times -1 happens inside parentheses. So we're changing the input value before we put the x through the function machine. So what this means for this function, it's fairly straightforward and fairly simple because multiplying times -1 and dividing by -1, kind of do the same thing. That is what I need to do here. I need to divide by -1, not multiply times -1, because I need to do the opposite of what I see in parentheses. In this example, there is no mathematical difference between multiplying by -1 or dividing by -1, but mathematically, you should do division. So -4 divided by -1 is +4. -2 divided by -1 is +2. And 0 divided by -1 is still 0. So if I plot these points at 4, -1 for my circle, 2, 0 for my square, and 0, 1 for my triangle, my graph, just extending the lines a little bit here, look like this for my t-graph. Okay. So you can see the slight subtle differences between reflecting across the x-axis and the y-axis. Both of our reflections are parallel to each other, but they reflect at kind of different points. And let me just write that down here, that this is a reflection across the y-axis. Okay. So this one is a horizontal change. And the first one was a vertical change. Okay. Let's move on to our next transformation. Next, we're going to be looking at vertical stretches and shrinks, and versus horizontal stretches and shrinks. And again, it will hopefully help you to kind of track those X's and see how they move on a vertical stretch or shrink. And again, the thing that makes it a vertical change is that the x-intercept is staying the same. And with horizontal stretches and shrinks, you can see what's happening to the target point that we're following. And the key thing here is that that y-intercept is staying the same. So how do you do stretches or shrinks? Notice that there's a multiplication factor involved. That multiplication factor is either outside the parentheses or inside the parentheses. And if a is a value bigger than 1 and it's outside parentheses, that causes a stretch, a vertical stretch. If that a value is less than 1, that causes a shrink, a vertical shrink. If we're talking about the horizontal direction, remember, horizontal changes are the opposite to what you expect. If that a value is greater than 1, you have to undo that change. It causes a shrink in the horizontal direction. Remember, you have to undo that change because we're talking about it making a change to the input value, and you want to end up with the same output value. Okay. And then if that multiplication value is less than 1, that causes a horizontal stretch. So let's look at our parent function again. We've got x minus 1 is our parent function. So if I just label some of these points at 0, -1 is my circle, 1, 0 is my square, and 3, 2 is my triangle. And now for my first transformation to graph h of x, I want to take that f of x function, my parent function, and multiply the output times 3. I'm doing my multiplication by 3 after I've put x through the function machine. So I'm going to plug in 0, and then what do I get out? I get my output. I basically just multiply times 3. So -1 times 3 is -3. 0 times 3 is 0, and 2 times 3 is 6. So if I graph all of these points, I now have a point at 0 and -3 down here. A point at 1, 0, so that point is the same. And a point at 3, 6, which is up here, not quite on the graph. And then if I do the best I can, let me just have a extra point here to help me draw a straighter line. Okay, and that's my graph of H. And now let's look at what happens when we, oh, sorry, let me just summarize that. This was a vertical stretch by a factor of 3. Okay, and I know it's a vertical stretch because my x-intercepts did stay the same. Now I'm going to look at another transformation. This time I've done multiplication, but the multiplication is happening inside parentheses. It's happening to x before x goes into the function machine. Now, remember, in order to get the output, the same output that I had before, and I'm multiplying that x by a third, in order to get that same output, I basically have to do the opposite of multiplying by a third. I need to divide by a third, which is the same as multiplying by 3. So I need to take that input and I need to multiply it by 3 to get the input back to that original 0 value that gives me the -1. Changing those input values. 0 times 3 is just 0. 1 times 3 is 3, and 3 times 3 is 9. So my 0, -1 is actually the same. That circle point has not moved. But then +3, 0 is a point at the line, and +9, 2 is a point on the line. Oh, I should have made those different shapes. This is my square, and this is my triangle. And if I just do the best I can to kind of draw a line, let's see, 1, 2, 3 over 1, 2, 3, 1, 2, 3. That gives me a little bit more to go on to hopefully draw a slightly better line. There we go. And that's my g function. So here you can tell that this was a horizontal stretch by a factor of 3. It looks like I multiplied by 1/3, but really this was a horizontal stretch by a factor of 3 because it's happening in the x direction that changes opposite to what you expect. Okay. In terms of what you need to know, I understand that kind of thinking backwards and finding the correct input values when the change has been inside parentheses can be difficult. It is always okay to make your own just XY chart and just make up whatever X values you want and plug it into the equation and get your output values and choosing to graph those instead. That is always okay. I wanted to show you why the input values had to change to get you the same output values as you had before. Changes in the vertical direction are usually easier to understand. Changes in the horizontal direction can be more complicated. But you have two approaches. Either just doing an input-output table if you need to make a graph. And the other thing is to just look at the change. Quite often, all they ask you to do is just describe what it is. It's a horizontal stretch times 3. And all you need to do is realize I've got multiplication that's inside parentheses. And so the change is opposite to what you expect because the change is inside parentheses. And therefore, this is a horizontal stretch times 3. Let's look at another transformation set. Here we've got a graph of f of x plus 2. And my data points, I just make some shapes up here. -4, comma, -2 is my circle. -2, comma, 0 is my square. And 0, comma, 2 is my triangle. And now I'm gonna make, let's see, this time I have multiplication times 1/4 happening outside parentheses. So it's happening to my output value. So what I'm going to do is I'm going to take my original output value and multiply it times 1/4. -2 times 1/4 is -1/2. 0 times 1/4 is 0. And 2 times 1/4 is +1/2. So if I graph these points at -4, 1/2, 0, I'm sorry, -2, 0, and then 0, 1/2. I just extend this pattern here, extend in this direction. And try to draw a decent line in here. You can see that what we have for graph K here is a vertical change, but this time it's a vertical shrink. It's like somebody's kind of sat on this graph. So this is a vertical shrink by a factor of 1/4 because the change is outside parentheses. Let's look at function j here. We're multiplying by 2, but we're multiplying inside parentheses. So changes inside parentheses mean change in the horizontal direction. And changes in the horizontal direction are always the opposite of what you think they are. So instead of multiplying by 2, we're actually going to need to divide by 2, or multiply by 1/2, however you prefer to think of that. Divide by 2 to get the new input value. So this is going to be a horizontal shrink by a factor of 1/2. Okay, dividing by 2, multiplying by 1/2 are the same thing. So let's see, -4 divided by 2 is -2. -2 divided by 2 is -1. And then 0 divided by 2 is 0. So our new points will be at -2, -2, which is, that's my circle point. -2, -2 is right here. -1, 0 is my square point. And then 0, 2 is my triangle point. And then just kind of continuing this pattern on a little bit to help me draw a better graph. The graph looks like this for the function j. So here we've seen what vertical shrinks and horizontal shrinks look like. And again, with the vertical shrink, the x-axis, x-intercept stayed the same. For the horizontal shrink, the y-intercept stayed the same. So far, all of the changes we've done have only made one change at a time, one transformation at a time. And so let's look at an example where we do multiple transformations. When you're combining transformations, you basically apply your transformations in PEMDAS order. So you are going to think about your stuff in parentheses first, because that's the P in PEMDAS. Then any exponents, which we don't see yet in linear equations, then any multiplication or division, and then any addition, subtraction. So here we have a graph of f of x equals x, kind of the parent linear function here. And they want us to graph this equation, which has a multiplication component to it and an addition component to it. So it can help to kind of rewrite g of x in terms of f of x. So it's like we took that f of x function there and we wrote it as g of x equals, we kind of multiply it by -2 after we've processed f of x. And then we also add 3 afterwards. And this is what I'm going to move on to describe, but you could make the argument that the multiplication happens inside parentheses. You could have said g of x equals f of -2x plus 3. That would be a correct interpretation as well. But right now I'm going to focus on the purple graph. So I've rewritten this function in terms of x so that I can really focus on what's being added, what's being multiplied, and at what time I'm doing the adding or the multiplying. So step 1 asks me to think about any horizontal stretch, shrink, or horizontal stretches, shrinks, or reflections if a is inside parentheses, if I've got a multiplication factor inside the parentheses. In this example, there is nothing inside parentheses, so I'm not going to do anything. No a inside parentheses. So I'm going to move on to step 2. Step 2 is a horizontal shift if h is inside parentheses. There is no h inside parentheses, so I'm going to skip this step. Okay. Step 3 is taking care of any vertical stretches. If there's an a multiplication factor outside parentheses, and here I do have an a value outside parentheses, so I'm going to a equals -2. So there's going to be a vertical stretch by a factor of 2, but also a reflection because the 2 is negative. So from this step, I can see that there's going to be a vertical stretch times 2, and there's going to be a vertical reflection, a reflection across the x-axis. Okay, because of that -1. So there are kind of nothing happened in step 1, nothing happened in step 2, but now there are 2 things happening in step 3. So what I'm going to do is I'm going to take, uh, kind of think about that point. I'll think about this point, and I'll think about this point. And the 0 isn't going to change. The 0, 0, the origin isn't going to change at all with the vertical stretch or the vertical reflection. But here, instead of going up 2, I'm going to double that because of the stretch. I'm going to go up 4, but it also needs to be a reflection. So I'm actually going down 4. I'm coming down here and plotting a point at 2, -4. Taking the triangle point, I want to take that -2 and double it because of this vertical stretch of 2. That takes me down to -4 down here, but I'm also have a vertical reflection. So I'm actually going up here to +4. So this is kind of my in-between step just right now looking at step 3. Moving on to step 4, that tells me to do a vertical shift if there's a k, if there's an addition portion outside parentheses. And there is, we add 3 outside parentheses. So this means so k equals 3. And so there's going to be a vertical shift up 3. And so my triangle moves up 1, 2, 3. It's kind of up here in the sky. This circle goes up 1, 2, 3. And the square goes up 1, 2, 3. And so my final graph looks like this. Just for a little bit more practice, let's go ahead and look at this other version of the equation. This time, when we do step one, there is a horizontal stretch inside parentheses. So a equals -2. This is a different version that we're doing here. And so we're going to have a horizontal shrink times 1/2 and a reflection across the y-axis, a horizontal reflection. Reflect across y-axis. So now what we're going to do is go back to those original red points that I plotted. And this time I'm thinking about the horizontal direction. Here, if for the triangle, I was at negative 2. I think I said the y direction. I meant to say x. But here I'm at -2, and I'm going to cut that in half. I'm only going to go to -1. But I'm not actually going to be here at x equals -1. I'm going to also have a reflection where I come over here to the +1. Um, and then for the circle point, the circle point actually stays the same because it is the y-intercept. And this square point here, I'm going to cut it in half. So instead of being out here at x equals 2, it's at x equals 1. But I also need to flip across the y-axis and plot a point there. So you can see that kind of my intermediate dotted line here is in the same place that my intermediate purple dotted line was. When I look at step 2, it asks me to look for an h inside parentheses. There is no h value inside parentheses, so we're going to skip this step, just like before. When we get to step 3, it asks us to look for vertical stretch outside parentheses, a multiplication factor outside the parentheses, and there is none, so we'll skip this step. And then last, it asks us to look for a vertical shift k value outside parentheses. So this is going to be a vertical shift up 3, just like it was before. And of course, our dotted line is in the same place as before. So our final line is in the same place that we got before. So no matter how we look at this particular multiplication problem, whether the multiplication is happening inside parentheses or outside of parentheses, we end up in the same place. There are more complicated functions where you definitely have to view it in one way or not the other. But in this case, it didn't actually matter which view we had of this function. Next, let's move on to a real world problem. Let's look at a real world example. This says the cost of cable service for m months is represented by the function f. And f is the black line here on the graph. To attract new customers, the cable company multiplies the monthly fee by a factor of c. So multiplying the function by a factor of c. So that's represented by this blue graph here. The company then adds an installation fee of k dollars. So the red graph shows the kind of G graph that has then had k added to it. Use the graph to find and interpret the values of c and k. So first of all, what is the value and meaning of c? What is the multiplication factor that causes the transformation from the black graph to the blue graph? And we can see here that this is it's kind of like a discount rate that takes a point like, let's find an easy to track point like this. At 3 months, this value is 180. And then when we go down to the blue graph, that value isn't 180. That's actually, let's see, if this here is 100, then the line in between is 90. So we seem to be cutting the value in half. So we're taking that C value is some sort of discount rate of like half off. Okay. So uh, the cable company has kind of their normal charge, and then they're offering somebody this 50% discount, this half off special. What's the value and meaning of K? Well, this often happens. Companies, let you save money in one area and then tack on an extra fee in another area. So because they're making less money because they're giving you a 50% discount, they do charge an installation fee. So instead of actually costing $90 after 3 months, we're actually up to here, this value instead, which isn't as high as 140, it's only 130. So, kind of between the 90 and the 130, that's an extra $40 that's unaccounted for. And that extra $40 is that initial kind of installation fee. Installation fee. Um, so that installation fee is $40. And if we kind of backtrack back to the beginning of the red line, we see that even if the person gets 0 months of cable, they still have to pay that $40 fee up front because that's that kind of upfront installation charge. How much does a standard customer pay per month? We're basically asking what's the slope of the black line? Because then every 1 month, how much does that line go up? Well, when we go over to the right 1 month, we go up to the 60 mark. So the regular kind of customer seems to be paying $60 per month. And then how much does a new customer pay per month? Remember, this is the slope of the red or the blue line. The red and the blue line actually have the exact same slope. Um, uh, but we'll go ahead and look at the red. We kind of start here at when 0 months, we've got a cost of $40 per month. And then here at 2 months, we've got a cost of $100 per month. So kind of figuring out the slope is going to be the 100 minus 40 over 2 minus 0. So we're talking about 60 divided by 2, which is $30 per month. And of course, we could have just taken our answer from part C and combined it with our answer to part A. $60 per month is what the standard customer pays, but we got half off, so we're only paying $30 per month. And so that's how we can kind of use these transformations, graph transformations, in a real world context. I hope this helps.